Hey Venkat, how are you?
Good, how are you? Yesterday I could not join actually, so
No, yesterday there was no class. I pinged, right? I
oh,
was not well, so.
oh, sorry to hear. I didn't even notice actually.
Oh, okay. Nice. That's okay. We cancel that. Hey Narayana, good evening. How are you? Okay. All right. Okay. So how is the practice and other things going? Guys, how are we doing on the practice?
Last I practiced Azure, what is that? I forget what it is. On Azure,
Mm-hmm.
uh, yeah, autoloader. I practiced.
Oh, awesome. Nice.
Yeah, with the
So you
help of
should
Murali.
you should demo it. You should do the certification. What am I talking? I'm still not well, really. Uh,
Okay.
you should plan the use case and demo it.
Yeah, sure.
So we are almost like this. I'm running through this, right? So we almost covered most of it, and a few topics I will cover today. These are more, as I said, right? More to know the concepts, right? Just to know things, how they are, how they work and what are the features and all of that, so that you are aware of when you talk to people or when people are talking about it. At least you should connect. Yes, yeah, I know that. Yes, that's how this works, and all of that. So when we talked about Databricks, we talked about lakehouse architecture, we talked about medallion architecture, the lake house and medallion architecture. We talked about delta files, the format, delta format. Then talked about all the features of delta. What are the features of delta? How does it support ACID transactions? uh, you know the uh, they have a transaction log. You can do time travel, rollback, right? And then you have, it supports deletes. Then you have vacuum command to remove the deleted ones, uh, to support GDPR and CCPA requirements. um, you have data lineage that can be built when you're seen in the DLT or through workflow or through a job or in your run. You can build, so it writes the audit, so you can build the lineage and see it helps in troubleshooting, and it's also in the regulatory requirements. All of these are advantages of using Delta. Then you have Databricks SQL, how you use DB SQL. Then we talked about Spark internals, how actually everything works under the hood. We talked about the Spark um, join strategies, performance improvements, adaptive query execution, um, and the how it chooses based on the cost dynamically, the all of the join strategies, right? There are other features also of Delta that we will touch upon. So Unity Catalog is one of it. Hive Metastore versus Unity Catalog that we will touch. But looking at this, right? So did we cover all of this? Or do you think anything we have left other than module 8? We covered jobs, workflows, distributed computing internals, ACID storage. This is part of, we did kind of rollback, time travel, insert updates, and all of that. Merge statements, streaming, batch processing, foundation, certification, content, practice demos, and all of that, right? The live tables and all of declarative way. So we will be touching upon this today: Unity Catalog, Metastore, DB SQL. Is there anything else you think we missed, or anything we wanted to talk about? Guys, anybody? Shanmuga, Murali, Srini? Do you think we have covered all of these, what we have put in here? Practice demos, yes, we will start with. Subbu, autoloader demo this week, from next week, and other people also. I want everybody to give some demos, only then you will get confidence, the actual work, like you have actually worked. At least 20 to 30 minutes of demo. Any use case, just simple, take some data sets. But I prefer data sets which we have not covered in the training. We don't want to use the same data set, same transformations. Take any new data sets or new use cases. Try if you can connect to any external sources, and then pull the data, right? And there are some use cases I will also give you, but go through it, do a prepare the use case, do a demo, walk through what are the sources, how you have read using the streaming or batch, what transformations you have done, how you have written to the uh, Databricks tables, the gold, what aggregations you have done in the gold, all of that, and any new features that you have are exploring, advanced topics you want to talk about, at least, even if it is not a code demo, advanced topics if you want to talk about with the Databricks product, right? So that we will cover. But as of now, are we good with all of this?
Yes, sir. Yeah, only thing is the first things are okay, but I went through those, the theory things, that computing and all those things, right? The last couple of classes.
Mhm.
So the thing is actually, yeah, I stuck somewhere because I'm going to those the notebooks. Some of the things are not working. Maybe I need to download those kind of the stuff and everything first, right? Like Amazon database and everything. I need to download. Maybe, yeah, I need to do more practice on those things. And a couple of things I observed, because I don't know whether we covered or not. Because in those classes, I see there are some RDD things as well. So I don't know. So when we use the RDD and when we use the data frames, so what is the main difference between these two? And when we will use, the scenarios wise, so when we will use the RDD and when we use the data frames. So these kind of questions I have actually. So I don't
Yeah,
know whether we
sure,
covered
sure.
or
I
not,
think
but
we discussed about that, but I'll talk about it. It's no big deal, right? So RDD, I remember I talked about it. RDD is resilient distributed data set. Okay, that's the base building foundation building block of Apache Spark. Okay, it's nothing
yeah,
but it's RDD is just a data set. Data set means you have data. Okay, now the data is not structured. It does not have a schema. Okay, it's just a kind of comma separated values or strings or whatever it is. It is distributed. We talked about distribution, right? So it is split into multiple
yeah,
nodes, partitions, and all of that. It is resilient because anytime you build an RDD or a data frame, it is not lost. It's built based on the transformations which it kind of stores like a DAG, right? So if you lose it, you can always build it back using the DAG, where whenever you call that data frame or whatever, it goes back and reads, correct? It's a resilient and it is immutable. You cannot update, change it, whatever RDD you have or data frame you have. You will always create a new RDD or a data frame whenever you do some transformation on that. Now, what is RDD? What is a data frame? So when Spark started, it started with RDD. Then it evolved into data sets. Okay. So data sets then evolved into data frames. The underlying component is still called RDD for the data frame, but that is all underlying. Now we don't directly work with RDD. So initially, when we started about 5, 7, 8 years ago, all we used to, everything was RDD only. So whenever you read something or whenever you get data, it used to return RDD object. Then from RDD, we used to add a schema to it and then create a data frame. Then use the data frame. Now later it evolved and now it automatically gives you a data frame. So data frame is just that it's an RDD plus schema. That's all there is to it. Okay. So there is no confusion. RDD and the data frame. So RDD is just a component of the data frame. RDD plus schema is called a data frame. Okay, did you get it?
Yeah, yep.
Let's see.
Yeah.
We'll
Because
just.
I'm seeing there are some scenarios
RDD
where
means it's only data, you can say, Harun. RDD
Yeah.
means only data.
Yeah,
It's
it's
a
just the data that you get. See,
data frame means it's structure with the data.
RDD was primarily user-facing API in Spark since its inception. At the core, it is a immutable, distributed collection of elements of your data partitioned across nodes in your cluster that can be operated in parallel with low-level API that offers transformations and actions. So this is a low-level API underlying. When it started with RDD. It's just collection of elements of your data. Okay. If you want low-level transformation, you do it, but almost all of the times you don't need to go to RDDs at this time. See, we did use RDD. Remember, if you still want, we can go back and say in one of our previous classes we did caching. Remember, we did partitions. How many partitions it has? Let me open that for you guys.
It's a low. What exactly the meaning of low level transformations?
It's
Just
not low level API, which means see, sometimes you don't want to use the abstraction at higher level. You want to dig deeper and go to the element level.
okay.
Okay. That is called low level. Say, for example, when you are reading data from any of the external source, for example, okay, database. So how can you read that? You can use JDBC connectivity, right?
Yes.
So JDBC connectivity you can use and pull the data.
Yep. Okay.
Then if the source is giving you an API, REST API, so you can use the REST API and pull the data, right?
Yeah, that's
So
true.
they will handle that whatever information you're sending
Sure.
through API, they will collect all the information on their end and send you back as a response. So
Okay.
that is high level, not low level. Low level is you're directly connecting to the database using JDBC and pulling the data yourself.
Okay.
API is some service they are providing. You just go and give your request, they give you response. That's the high level. Now take more advanced. There are connectors that are already built by them, like
Okay.
Salesforce. If you want to integrate Salesforce to Databricks or any other or Informatica or any other ETL tools, they default give you some connectors
Okay.
for each object type. Okay, customer, there is a connector. You just use customer. But
Okay.
why do you want to use connector for customer? You can use JDBC connectivity. You can use API. Then why do you want to use connector? Which means that's a much advanced. At JDBC, you have to take care of your network connections. You have to take care of security. You have to take care of the all of that stuff, connection, network, breaking, IO. And then you have to figure out which table you want to access. Then you have to have access on that tables. They have to provide you access for that user that you are connecting, right?
Yeah.
All of that is low level, but you have control to directly go to the table. Well, if you have access and all of that.
Okay.
But
Via
high
API.
level, yeah?
Via API only.
No, by JDBC I'm talking. So next you go to API. API is controlled. They give you access. The API will have access to whatever underlying. So that process is not in your hands. Only you can only do request.
Okay.
Okay. The service is provided by the a vendor who is giving you that API. So they will do processing, get the data and give you. That is API. Now in the API, you lose some control, but you gain some advantage that you don't have to worry about network, IO, all of that. The API performance will take care of it. You don't have to go to JDBC connection tables and all of that. They will give you API, what you call the request response, what you have to send as a request, what values, what attributes you have to send, and what they will send you in response. Now, if you go to connector, that will give you more advanced features like, if they have multiple objects, they will connect. It will store, it will give you CDC. What are the records that has been changed since last you read? So there are more features that are added and more control, more functionality. They add to that connector so that all your housekeeping jobs are taken away. You just connect, use the connector, get the data. That's all. So that is high level. So basically, it's the same thing. RDD is still at the lower level, but you build kind of data frame. So from Apache Spark 2.0, RDDs, you can seamlessly move between data frame, dataset, and RDDs by simple API method calls. Data frames and datasets are built on top of RDDs. Okay. Data frame is also immutable distributed collection of data. Unlike an RDD, data is organized into named columns like a table. That's it. So if you see here, an RDD plus schema, columns and data types will give you the data frame. So data set is also there somewhere in between these two, but not widely used. Typed API, untyped API, some kind of object. I mean, at least I have never used a data set as is. But in Python, the data frame only, data set is not available. Data set is only available in Java and Scala. Since I've not much used this, so it's data frame. It's data frame and RDD. You don't need to worry about data sets and all. Okay. Not much used. So that is the example between RDDs and data frames. Got it? So when you say high level or low level, don't worry about going into the, are we going deeper on the, so RDD is already there. It's just that there is another wrapper that is built on top of RDD, which we call data frame, where you by default give the schema to it. If you don't give it, automatically create some default schema for you, right? When you read a file, if you don't give schema, if there is no header, it'll automatically give column 0, column 1, column 2, and assume some inference data type. So you get the data frame. It's like a jar inside the jar, the core. Okay. Let me show. Where is this? Log back in. Where is this? Is this the one we did last time? You see here? df3.rdd.get num partitions. Here, can you see? Murli?
Yes, sir. Yeah, that's what I got actually.
Okay. So number of partitions is at the lower level. It's a low level API. It's not at the data frame level. It is only at the RDD level. So what we do is from data frame, we convert to RDD and then call that API or call that function method to get the partitions. So we cannot get the partitions directly from data frame. So underlying in the data frame, the low level component is RDD. So the partitions, number of partitions function is defined at RDD level. So when you go to data frame, you have to first get the RDD from the data frame and then get the partitions of that RDD. So if you just say df.rdd, you will get the RDD and then you get the partitions of that RDD, which is basically the partitions of the data frame. Simple. That's what we call low level. You can directly just simply convert df.rdd. So RDD also you can convert to data frame. There are functions like, when you give to create RDD or create data frame using some functions and you give the data and then you give the schema. Then it will create a data frame. So those functions are also available. It's compatible both ways. But this is how you can convert data frame to RDD, get num partitions and back to data frame kind of. Okay.
So how frequent we use this RDD in real time?
Why do you want to?
No,
Right.
I'm saying there are different scenarios if you want to
There
call
are
it as.
absolutely. See, I haven't at least seen anything that is there. You can want to work with RDDs, which is not available in data frames, except for if you want to see partitions. See, both are same, like except just with
Yeah,
R
because the
plus.
scenarios sometimes I'm seeing that RDD dot some mappings and some reduce and those kind of stuff.
No. Those are all legacy now. You don't use RDD, map reduce. Map reduce is all like legacy, original algorithm basically. That is all this distributed computing came from map reduce algorithm, right?
Yes.
So
Yes.
last week we were seeing, right, how the data is distributed, how the instead of the data coming to the function, we send the function to the data because data is now on multiple machines. We send the processing or the function programming logic transformation to each of those partitions data, and it gets executed. It runs on those partitions. Then we reduce all of this to combine the final data. So that is mapping and reducing. That's the algorithm. First, it started with Hadoop. Okay, about 10, 15, 20 years, map reduce. It's called it's more like a concept, how to do distributed computing, splitting the data into multiple nodes, multiple partitions, processing it locally, and then combining all of that information to get the final output. So that was the algorithm. You do map and reduce. So initially, when you started with uh, distributed computing in Java, they used to write the map reduce programs about 10, 12 years ago, 10 years ago. They were actually used to write map reduce programs. They used to define map function, they define reduce function, a lot of complications kind of thing, jobs that runs the map reduce algorithm to do the distributed computing. Now, since it has evolved so much, even I have never written a MapReduce program myself. Okay. Since it has evolved so much, all of that is now taken care of. The other day also I was saying, we used to calculate how much cluster size, how many machines you need, what is the size of each machine, how many cores it has, how many executors we need, how much memory we need. So all of that we used to calculate, right? But as the time is advancing, right? So the features are getting more and more advanced. All of that is taken care of by the platform provider. You use elasticity, right? Auto scaling. It will automatically increase or decrease the machines. Now it is going to serverless. You don't even talk about what machines. You don't even choose, right? At this point of time, you're choosing at least the sizes of machine and number of machines you can go up, down. But when you go to serverless, even that is also taken away. You don't know what machine size it is using. You don't know how many machines it is going to use. Right? So the more and more advanced features, you have to focus on how I do the functionality rather than worrying about housekeeping, administration, networking tasks. So that is why the platforms are more and more getting advanced and taking away all of that complexity from you so that you focus on writing the actual transformations, what you want to do with the data. Okay. The how part is being more and more taken care of by the platforms. Now, if I have cluster now, I have serverless now tomorrow after 2 years. Now I go to the client and say, hey, I want to define a what you call cluster with master and nodes. I want to define 5 machines. I want to define this RAM, these partitions, these executors. Can I go and create? Will you ask that client?
No.
I will put fixed number of machines. For each job, I will calculate how much memory it will take. Then I will create those nodes. I will create that cluster. And then I will ask jobs to use that cluster. I will use that cluster only. If you go and you'll say, okay, I will take a week or 1 week to define all of that and get correct requirements for how much memory we need, how many machines we need. Do you think that will be practical? What, Murli?
Yeah, no, Arun, yeah.
All right.
Yeah,
Yeah.
only thing is, just
So
like,
basically, we don't want to go back and do the things that are already legacy and now being taken care of by the platforms and the latest evolutions and features. Those are there just to know. In olden days, it was done like that.
yeah, no, my
Yeah.
point is, if interview they ask, are you work for the RDD and what kind of means? So
No,
you can.
that's what right. That is what y'all. Nobody will ask you, have you worked with RDD?
Oh, okay.
When they say RDD, yes, I know RDD is, that's what you just have to know about it. That's it. You say, okay, RDD is just a component of data frame. Data frame RDD is just the data without schema. When you add schema, it becomes a data frame. I worked with data frame. The underlying you can still get RDD and then low level API. It's like I used RDD when I wanted to see how many partitions the data is and when I want to do repartition. That's all. But other than that, no, we don't actually need to go to RDD. You have to tell them, yeah, no, why do we want to go to RDD? I never needed to go there. Everything is there in the data frame, right? Very rarely
Yeah.
you might need to go to RDD, but I have never came across the the need to go to RDD except for partition. So, but
Yeah,
that's what
some
I
kind
said.
of scenario.
You should actually, yeah, you should know understanding concept, right? So when you say, have you worked with RDD? If that is the question, you should not say, no, I don't know what RDD is. I know I have never worked with RDD. If you stop at that, then they will know, oh, this guy doesn't know what he's talking about. It's not that they want to see whether you have actually worked with RDD. They want to see if you understand what an RDD is or you are just you have knowledge or not. So if you say, no, I have not worked with RDD, but I know RDD is just, you have to talk about what is an RDD. RDD is part of the data frame. It's Spark, Apache Spark started with RDD. You have tail of three elements: RDD, dataset, and data frame. So it started with RDD, then there was dataset for Java and Scala, but then they created data frame, which is RDD plus data plus schema. When you add schema to RDD, it becomes a data frame. And RDD is a low level data element, which is there already there. And data frame is just a wrapper on top of the RDD. So all your APIs, all your functions, methods, everything is in the data frame. So we don't need to go to RDD really. If you just say that, yes, it's good. He's not going to ask further any questions on RDD. Or you can talk about, I know it's a resilient distributed data set. You talk about it. You don't have to say, I didn't need work with it, because RDD was Spark 1.0. After 2.0, you got data frames to work with. Unless you say that I have worked with Spark 1.0, then you say, okay, I worked with RDD when I was working with Spark 1.0. Okay. So it doesn't mean that everybody would have worked on everything, but at least you should make them let them know that you know all these things. You have the knowledge. Okay. And then you can talk about it. Okay. All right. Shall we move forward? Are we good?
Yeah.
Okay.
Yes, sir.
Awesome.
Yeah.
Awesome. Okay. Yeah. So I'm also going some more about more concepts, right? It will be more like kind of theoretical but exciting features that you should know about the Databricks ecosystem, right? The Lakehouse platform that we are talking about. We will run through a presentation. This is from Databricks itself. Not this one. Not this one. This one. Not this one. 1 second. Let me get that. Where is this? I had that open. Okay, I got it. Okay, so we talk about the Databricks Unity catalog today. So this is a very important component in the Lakehouse architecture. So you all have seen the Lakehouse architecture multiple times, right? And then there is always a horizontal bar called Unity catalog. And that is what we are going to focus on. How is this Unity catalog central to everything, and how is it binding all other features or enabling other features in the Databricks? So this is provided by the Databricks technical pitch deck. We will go through this. I know it will be a little dry because you're not doing hands-on practical, but you can still see some of them. You can do practical as well. So you see here in the middle, Databricks Unity catalog, governance model for structured and unstructured data plus AI. You have to be very comfortable using these terms. Unity catalog, governance model, data governance. So that's what you have to continuously talk about. Okay, governance, data governance. What is data governance? We'll come to it. I will talk about it. We'll run through this. I want to just where is this? Okay. So if you see here, Lakehouse platform, right? We're talking about. So any Lakehouse, any slides that we talk about Databricks architecture or Lakehouse platform, So we have talked about this as well. So there's a Unity catalog here. The underlying raw data where you're talking about text files, audio, video, images, logs, the source files, right? And then you have a layer on top of that, delta uniform, which is your delta files or Parquet files or uniform format, right? The arrow, Apache arrow. So all of those, the files that are converted or processed in this format. There is a Unity catalog on top of that, which takes care of your security, governance, and cataloging on this. So on top of this, you have all of these like Mosaic AI, data science and AI, ML and AI, Delta Live tables, ETL and analytics that runs on this, workflows jobs that use the Unity catalog, and SQL also that kind of interacts with the Unity catalog. So this is the layer that takes care of your security, governance, and cataloging. Okay. So now we are getting into the data intelligence platform. It's more like you're adding more features here. So where you get LLMs, create, tune, and serve custom LLMs, model serving, create adding the LLM models into your Databricks platform. So that is adding intelligence, AI, BI, Genie. You see here text to SQL, text to visualizations. These are all advanced features that are coming to SQL, where instead of writing SQL, you will go and do the write text, and it will convert to SQL and it will get all the information back. Or it want to create a visualization from the text, create a dashboards or something like that. Workflows and Delta Live tables with the data quality. So this is evolving into data intelligence platform, data intelligence engine. Yeah. But underlying that, again, Unity catalog. See, you securely get insights into natural language. So all of that security, governance, and everything again is taken care of by Unity catalog. The underlying data is actually in the Delta Lake, your tables, files, and all of that. So it is building layer by layer. And at this part, it has to pass through Unity catalog to go to Delta Lake or to go to external files, where all your security and governance is taken care of in the Unity catalog. Guys, do you understand?
Yes,
Yes, sir.
sir.
Okay. So this is the feature of Databricks Unity catalog that has all your catalog tables, all the components I will walk through right now, but it takes care of security and governance. That's what you have to talk about: security, governance, and cataloging. Cataloging means metadata, to see what are all the catalogs are there, what schemas are there, what tables are there, what views are there, what are volumes, what are external locations, what files, everything. It's like menu, right? So only if you menu and catalog which item is where, in a warehouse, there is a catalog, there is a menu item where you know which part or which item is where in the warehouse. Even if you go to IKEA, you have numbers. You can go and pick up that item from there. You'll give the shelf A13, right? So you go to that rack A and then you go to number 287 and then you pick up those boxes, right? So something the same, the catalog, what it has. Governance and security, that we'll talk about. So that I wanted to get started with that introduction. Okay. So this is talking about the use cases with the Databricks intelligence platform. So you should talk about Databricks Lakehouse. It is continuously now evolving and becoming the intelligence platform. Databricks Lakehouse is now becoming the data intelligence platform. That's what you should talk about. It's still there. This is evolving. This is coming like evolving into data intelligence platform. So again, the same source and use cases. You have cloud storage, where you get files from the cloud, message queues, streaming databases you can read from, enterprise applications you can connect like Salesforce and other um, applications that you can connect to and pull the data in. You have compute where you can do simple compute, create your computing, what you call, you create your clusters, compute clusters, or you can now future will be serverless. That's what we were talking about. You don't have to worry about any of the size of the machine, number of machines, how many machines, upscaling, what is the maximum you can go down, how much you can come down. Nothing. Everything will be taken care of. You will be charged based on the usage. Governance model, again, that's what we said, unified governance using the Unity catalog. Reliable storage, yes, it is already there. You go with all of the cloud platforms where you can store, whether it is Azure, GCP, or AWS. So data intelligence, so you do data ingestion, transformation, warehousing, machine learning. This is already all there, real-time processing. Data intelligence engine where all your AI components are coming in, your orchestration, again, workflows, jobs, and all of that is there. And use cases, SQL analytics and BI. That's where we are talking about when we go to intelligence platform, the next evolving features are text to BI, text to visualization, text to SQL and text to visualization. That will automatically take care of, you just write a text prompt as a in the chatbot you do, right? Chat GPT. Same thing, you write prompts, it will convert to SQL and query your tables and then get the information. You don't need to write, select from this table, join this table on these keys and all of that. So that is now continuously being built into the intelligence here, data intelligence engine, where you can just go and add all your schemas to that engine, and then it will know what tables or what schema is there. And then you write text to SQL. You write a text, say, get me all the sales from my New York store. So it will go, it will understand, it will go to schema, it will try to see what tables it needs. You need sales, so you need sales tables, so it needs what are all sales tables. Then it needs location. You're talking about New York, so I have to go to location table, get all the locations. What is the New York location called? Which tables I need to join? So and then write a where clause for New York and get a date and then get the data. Everything it will try, it will figure it out on its own. It will write its own SQL. It will fire up its own compute, serverless compute. It will run the SQL, get the results. One step go you go to visualization, use that data, it will start creating the charts for you or dashboards for you, and then just throws up the dashboard. So you just write a prompt, get me all the sales last quarter for all my US locations, show me in this chart. So it will do the everything, just like in a BI developer, you giving a requirements to a BI developer. You say, hey, I want a chart to show month on month sales from all US locations. Then the BI developer will go write requirements, gather all tables he needs, information he needs, writes the SQL, develops the application, and then get the data, build the wizard chart, whatever chart he needs, a pie chart or a bar chart, put this data in, and then create that wizard, deploy the application, and then give it to the user saying, hey, this dashboard is ready. And then you have to write, get the data, refresh the data every time you create views and say, hey, I'm not able to see the data. I say, oh no, it is refreshed once in a day or once in 15 minutes or 1 hour. So all this is the current process, right? People who are working in an enterprise should be knowing all of this. So that's how it goes. But all of this process is just being done in 5 minutes. Think about it. All you need to do is that requirement line, you put it, hit enter, everything is done. Now you're not seeing good result. Go back, change the prompt. That's it. You don't have to, scope creep. A requirement has changed. Now it needs another week. Now I have to change these tables. I have to change this chart. I have to change that. Nothing is there. Change the prompt, you get the new result. right? So all of that is the new use cases with the data intelligence platform. So this is the most recent, latest one. It was, I think they talked about in Data and AI Summit a couple of months ago. They showcased some Genie AI BI use cases there. So that's what is coming. AI ML apps, real-time apps, data sharing that we'll talk about, how you can share your data securely with third-party vendors and others, where you don't have to actually generate on a daily basis files, transfer it to them on a network. They go and see, hey, we didn't get the data today at 9 o'clock. Hey, the job didn't run today. We are seeing delays. There's a network issue. The file failed, job failed. All of this is being taken care of by data sharing. They can directly, two people go, or it's something like you give access, and then they take that token, they fire up an API, they get the response, something like that, temporary. So this is where the Lakehouse platform, Databricks, is going, evolving into the data intelligence platform now with all of these components, building the data intelligence engine, which is your AI and Gen AI and LLMs, all of that coming in as part of the processing engines, the architecture platform. Good. I guess I'm making sense.
So without a technician, so means a software guy, if you know the proper English prompting, so BI reports can generate it. So
Yeah, absolutely right. So it is amazing. It is scary. It is weird. It's all. But then that's how it's going to be. The world is going to be. 70% of the tasks, jobs would be AI based going forward, and that is why it's the time now for us to adapt, to move into the AI. Right. So that's where the jobs will be, data and AI. So you should start now. This is the foundation. The next to this is moving into Gen AI and AI world. Right. So this is the logical progression. That's where you should be in next couple of years. I mean, things are already happening. 2 years might be, it's not like, okay, there's 2 years or 5 years time. It's like weeks and months. The landscape is changing, right? Every week, every month, the landscape is changing. The new LLM models are being released. The features are being released. The capabilities are growing exponentially for us to catch up. Things which people, even before adapting, are becoming legacy. That's how it is. In earlier, if Oracle or something or a new application has come, it used to take 10 years to get, 3 to 5 years for people to know, to understand, to install, to adapt, and then 5 to 10 years run on that legacy. But these days, there is something that is coming, and even before you adapt, is like, it's legacy. Now there is something else that has come new. So it's moving at that rapid pace. And that's how we need to adapt for future. Okay. Now, so this is the landscape of the futuristic. It is in development right now. It's going on a lot of things. It's just that adoption is not very or as good as they would have hoped. So they're pushing the adoption on the Gen AI cases, the Databricks. All the companies are doing POCs, trying out, but very few are moving into production use cases. That's there. The next landmine, the gold mine is not the landmine. So that's where the next gold mine is, that Gen AI use cases going into production. There'll be a lot of market, a lot of skills needed, a lot of people needed there. But this is the foundation to go there. You have to understand all of this. Without understanding Databricks SQL, you cannot go to text to SQL, right?
Arun, so currently they do have the analytics and BI as well. So,
Sorry?
no, the analytics and BI is already implemented, the reports in the
No,
database.
it's not implemented.
Oh, okay.
BI is separate.
Because
BI is currently, as of now, you just give in your gold. See, I'm talking about 90% of the use cases, how it is like medallion architecture. There are sources, you build up to gold layer, you build aggregates, and you stop there. That is when the BI is coming in, like your Tableau or Power BI. They read those views that you create in the gold layer, that aggregations, and then they build the dashboards.
Yeah, why I'm asking, because the Snowflake, they already have that feature, because since it is a competitor, right? So that's what I'm asking.
Yeah. I think so. I don't know. I mean, so that's what I'm saying, right? This is the futuristic. It's much coming soon or already in place, but the adaptation we have not still seen. What do you mean Snowflake has BI?
Yeah, Snowflake, they can build the reports. I mean, the bar charts and pie charts or everything, just like the Tableau and Power BI, the reports there, right?
No, that chart
In
is already
Snowflake
there,
itself.
right? So that basic is already there, right? That there, even if you go to your Databricks notebook, all that visualizations are already built into the notebook itself. It can automatically do it can automatically do in the notebook itself. BI charts.
So I mean to say that analytics, any advanced analytics, that's what?
Yeah. So what I'm saying here is you give the prompt, it should give you the analytics and the visualizations based on the prompt, not building the visualizations
Oh,
yourself.
okay, based on the prompt, okay.
Yeah. You just give the prompt. In the AI Summit, you build a complete marketing campaign based on the prompt. Just give a prompt, it will generate the image, it will process the feedback, it will generate the image, it will give you the for example, what is the best location to open a new store, or which of my stores are doing well. So all of that, you just give prompts, it should give you the data and visualization as well. Okay. Let me show you something then. I know this is going all over the place, but this is good. These are all the features that we should be talking about and being comfortable with. Data engineering. I have Unity catalog. This is DLT video. There, I think I saw somewhere. Airflow to workflows. Delta live streaming. Should have it somewhere here. This is workflows. Databricks SQL. Yes, let's see here. So if you see in one of the videos in Databricks SQL, you have this is the lineage. See here, visualization.
The analysis.
Can you hear me?
Databricks SQL offers a full-featured SQL editor that allows you to author, run and
Guys,
schedule
are you able to see
queries.
this?
As you can see,
Yes, sir.
Yes, sir.
the
Okay.
SQL statement, reading
So you
from
have a
multiple
SQL,
tables
right? In
with
Databricks
specific
SQL editor. If you
criteria,
write the SQL,
identifying total revenue by region. You can also modify this query that suits your needs. This query will be executed on a serverless SQL warehouse, which comes online in seconds and is optimized for high concurrency workloads with minimal management required and capacity optimizations that lower the overall cost. As the query executes, you can use the query profile to view the query execution details, which helps you troubleshoot performance bottlenecks during the query's execution by detailing.
see, we were talking about query execution, right? The other day, how the query is executed, what happens in shuffle, grouping, aggregate.
Each
Here you can see how much time it is taking on each of
task's
those
operation.
profiling online.
When the query results return, and within the same editor, Databricks SQL gives you the ability to create visualizations. So for this query, Databricks SQL automatically suggests a visualization.
See here, it will automatically take one.
Databricks SQL
But
automatically
you can choose any of these. See? Any of this chart type to generate.
suggests a visualization type, but you have the option to customize with out-of-the-box chart types. Now, SQL is great, but you may require additional functionality beyond what's expressible with SQL. With the introduction of Python UDFs, you can define custom functions.
Okay, so that is adding the UDF user desired find functions. But to answer your question, Murli, so mostly it is Murli Subbu. So mostly it is like we have the basic BI visualizations that are already built within your SQL or within your notebook that you get. Databricks SQL. Okay.
Yeah.
Yeah, but we are moving much forward, much faster ahead with text to SQL and text to visualizations. I will check that video if you have. I will send you. You can watch the Data and AI Summit, the Genie AI BI demo that was done. Okay, and probably we can try to replicate that. Try to do that use case demo. If you guys take it as a challenge, work, and then demo. So come up with the use cases. Law, who wants to work on what, set up a time and then do the demo. Okay, so this is okay. We are on the AI-powered data engineering. Quickly, I will just run through 10 minutes. Actually, I wanted to talk about the Unity catalog, which is, built. So this is the lab environment thing, right? This we already did the lab environment kind of. So we can do this. This is what we wanted to talk about, Unity catalog thing. So we'll go back here. So are we good? Whatever we have talked about?
Yeah.
Yes.
Okay. So now we see the Unity catalog is central to all of that, all of the proportions, right? Now see here. Data and AI governance is complex today. So what does it mean? Is see, what are the personas you have profiles? Data analyst, data engineer, ML engineer, other applications. There are multiple personas, right? Where questions is where to discover the data sets, where are the models, notebooks, dashboards, can I trust the data and ML? So each of this persona can access dashboards, data lake, data warehouse, models, all of this. So it's like many to many. So data analyst wants data warehouse, dashboard, data engineer wants data lake, data warehouse, models, so all of this. Now on the governance team, how do I manage who gets access to what? How to secure these assets in the data lake? Who is accessing these assets? Audit, Are we meeting the regulatory compliance, right? All of these are the questions. How we improve this, how we answer these questions for the data governance. So what is data governance? Basically is your security and governance access. How do you give access? So normally anybody we have worked, we already know the structure. So everybody has a user ID, right? So user profile. So access is generally given to the user, but then we'll have groups. So the users will be added to a group, and then you give permissions at the group level. So whoever is coming in to that group, who the new user you add to the group will get all the permissions access what that group has. You remove that person from the group, he will lose all those access. So that's how the is done. But at the top of the groups, then you will have at the service principal, account level, kind of access or permissions that are given. So all that structure, how do you manage if you don't have all of this, right? That's what happens with this fragmented view of the data and AI. So this slide is just to understand disjoint tools for access management, incomplete monitoring of this, and what are the outcomes of this: non-compliance risk, data breach risk, costly data sharing, cross-platform data sharing, and all of these are the challenges, right? And then we have seen this where Databricks Unity Catalog comes in. That will sit in as a core, which will manage the governance model for both structured, unstructured data, AI, ML, everything, everything in the Databricks will be governed by the Unity Catalog. Okay. And then all of these can access, or the access to any of these interactions between these goes through the Unity Catalog. So data warehousing, data engineering, streaming, data science, ML, they go through Unity Catalog. External platforms, Amazon, Presto, EMR, Spark, all go through Catalog. Data sources, if they want to get data, put data, get data, go through Unity Catalog. External catalogs, just like Databricks Unity Catalog, you have Hive, you have AWS has its own Metastore or catalog called Glue, where it manages the catalog of all the objects. You can read, interact with that catalogs as well from the Unity Catalog. Data Lake, you have storage of files, Amazon S3, Google Cloud, GCP, Data Lake, ADLS, where the actual files are stored. You can read from there. Unity Catalog interacts with that access permissions. So basically, this is the central for all of this. Okay, so you don't have to remember each of these, what you're seeing here. Okay, Manasa and Shanmuga, especially for you. So, right. So don't get overwhelmed that we have to remember all of these things here. You just have to remember Unity Catalog is the central that does the governance, and all other elements or all other personas interact within them through the Unity Catalog. It can be data engineers, it can be external platforms, it can be cloud platforms, external sources, everything is managed through Unity Catalog. So once you get to Unity Catalog, what does it give you? It gives unified visibility into data and AI. Okay, it's one place where you can get visibility into all your data and single permission model for data and AI. There's only one model. All permissions only go through Unity Catalog. There is no other place you can go and give, or some other, its own permissions, it can give and run its own permission list. No, everything happens through Unity Catalog. AI powered monitoring and observability. It gives you a complete monitoring, auditing, and observability. Open data sharing. So we'll see how the data is shared across using the Unity Catalog. Data sharing or delta sharing, whatever you call it. So it gives data discovery through the tables that it manages using tags and everything. Access controls to control the access to these objects. Data lineage, we have seen in DLT how it builds the lineage between the data journey. Visualization of the data journey, how it is moving. Monitoring, we have seen monitor how can monitor all the jobs and things. Auditing, it logs all the activities done by the jobs and workflows. Data sharing that we'll talk about. So based on these features, all of these will be enabled or used. These features will be used to enable this. So dashboards, notebooks, models, files, tables, all can utilize these features. Okay. Again, to reiterate, so Unity Catalog, you have workspace and all of these will come here. Centralized metadata and user management. There's one place where all the metadata is stored. What metadata? Metadata about what catalogs you have, what tables you have, what the objects you have. Everything is stored or managed at a centralized metadata in the Unity catalog. And user management. What are the users, groups, what access they have on what kind of object and what permissions they have, all of this. Centralized access control. So you can control all this access from one place. Data lineage, it's the same thing that we have looked at in the data lineage, access, auditing, search and discovery, data sharing with delta sharing. It's called delta sharing basically. Okay. So reiterating all the features of the Unity catalog. Where are we? Sorry. So this is how it looks like without Unity catalog and with Unity catalog. So what is the main difference here? It's like shuffling. If you see here in a Databricks without Unity catalog, you have a meta store where all your metadata is there. You have user management, access control, cluster, warehouses. This is one workspace. Now, if you create another workspace here, again, you have user management, metastore, access control. So basically all your user management, metastore, access controls are all at the workspace level. This is what you have to absolutely remember and talk about. This is basically your Hive metastore. Databricks without Unity catalog, if you just have Hive metastore, each workspace will have its own metastore. And user management is at the workspace level. Metastore, user management, access controls, all these warehouses are at the workspace level. And you create new workspace, again, the user man. So basically the user here cannot access the objects in this workspace. Okay, they are fragmented. With Unity catalog, all these move at the central location. User management, metastore, access controls, they all move to one central metastore. So each region will have one metastore. If you create workspaces, your clusters and SQL warehouses are at the workspace level, but all user management, metastore, access controls are shared from the same Unity catalog metastore. Shared or controlled from the Unity catalog. Got it? This is the main crux of what is Unity catalog, what happens with Unity catalog, what happens without Unity catalog. Now, if we go here, I don't know if I have logged in, but at least we can see.
Can you go to that screen one more time?
One second. I'm coming back. We are not going away. 1 second. Let me compute. Create. Will take some time. Come. Okay, it's running. Let me go here. Okay. So this is one workspace, right? And then you have one, it says Unity catalog. You have one meta store. And then this is a Hive meta store. If it is Unity catalog is not enabled, so you only have one Hive meta store. You cannot have all of these catalogs built here. So everything will be under the Hive meta store. But if you go where you can have Unity catalog enabled, you can have all of these catalog, schema, and tables kind of. See here. This is catalog, schema, and tables, which is your Unity catalog enabled. 3-part namespace that to qualify a table. Okay. 1 second. Okay, so let's go back to, yeah. Tell me. You're asking something?
Yeah, just to understand this one, that workspace. Okay.
Oh.
Means okay. Means at a Databricks workspace level means here you say workspace in sense like a schema kind of thing, schema level access.
No, you can have different workspaces, not schema. Okay. So that's what I said. Catalogs are different, workspaces are different. So your each workspace can have the same catalog that can be shared, but depending on the access that you provide. Okay. So if you see here, I have 2 workspaces. Okay. So based on departments, you can give access which workspace will have access to which department.
Okay.
Okay. So sales can have one, ML team can have one workspace, and then the other team can have one workspace. So based
like
on that, you get access to that teams.
Okay.
Okay. The metadata is at the meta store level, which is one Unity catalog.
Okay.
In that, so if you go to catalog here, you will have these. If you see workspace catalog here.
Okay.
So this is the catalog, right? Now, if I go to this Databricks demo workspace, if I go to catalogs, see, I don't have that catalog here. Okay, because I don't have the permission for that catalog to this namespace, to this workspace for this user. Okay, so your permissions will dictate what you will see in each workspace.
Okay.
Okay, now with this, there is no way to share between workspaces. It's all at each workspace level. Your meta store, user management, each will have Hive meta store. But here you can share.
Okay.
Okay.
Let's take an example. Normally, you have 2 folders. Let's take as workspace as a 1 folder.
Yeah.
And you're defining, hey, this workspace, this folder 1 has access to 4 people.
Yes.
Okay. And this workspace 2 has access to 6 people. Okay.
Right.
Just maybe two are common in between. This is possible. Okay.
Yeah.
That means you're defining the roles at the folder level, right? Okay. That's called, you can say that's called here Databricks workspace one is at folder workspace one. You can define like that.
Yeah. I mean,
Okay.
it's how you easily understand.
Yes. Okay. And this is also at folder two. Just we define the user management, metastore management, all these access, everything. But when the unit catalog means the Unity catalog means that's you can say as a network drive. Okay. In the network drive, that's called as Unity catalog.
Yeah, you can call that. You can call that your accesses, who has access, which group has access, just like Unix, right? In Unix also you will have groups, you have members, you give access to groups, and whoever is the member of that group, you will get access. So we will see how you can get, if you go, we have a lot more things to cover. You will slowly understand. So this is okay. File based, you have credentials, you have external locations, managed data stores and volumes. Basically how you access files from Unity catalog, right? You have something called volumes. In that you can have external locations. Each volume or location will have credentials to connect to, and all of this is managed from here. So look at this. This is how we are seeing right now. Okay. Catalogs, governed namespace across file and database sources. You can access legacy metastore and foreign databases also by the Lakehouse Federation. So at the top, you have Unity catalog. In this, you can define catalog one schema. And in the schema, you can have tables, whether it is managed tables or external tables. We know that what is a managed table, what is external table. You can have views, can have models and functions. You can have volumes. Volume is just like, remember in Unix, you mount a volume. You can add it's just like a space folder where you add your files and then access those files from here, local access. You can also have foreign catalog, Hive Metastore, currently what we have. And then in that you have a default database, and then you can have tables, database and tables in the Hive Metastore. So you can access like main Paul, catalog, schema, and table name, catalog database, table name. Okay. And if it is Hive Metastore, you can say it's Hive Metastore.default.customers if you want to access this table. Okay. So this is how it is structured. Unity catalog, which is governing all of these catalogs within this name UC workspace or Unity catalog enabled. And this is the Hive Metastore, both. So how do you get central access? What are we talking about is, so you can give grant. What do you need on select, modify all privileges, right? So you can give using SQL grant privilege on this table to, or this name to this. So grant select on tables. This is the table, collection of files in SD, whatever it is, to this group engineers. So whoever is part of that engineers group will get the select access on these events table, which is like basically a bunch of files. So this is how you control the access in the Unity catalog. Did you get this?
Yes, sir.
We can. It's standard wherever you go, right? If we just go here. Why is opening every time new thing, is it? How many times I will open this? Okay, so you go to catalog. You go to this. And then you see in the table, you have overview sample data that we know. Tables, what type of table it is, who created all this audit log is there. Permissions, if you go here, you can do grant. So this will give you on this table who you can give grant to. Okay, all account users, I have one principal. You can create new principals, which are basically groups. And then for that group, you can give what permissions you want. You want to give select on this table. You want to give all privileges like apply tag, refresh, select all privileges to this table. You can give here. Okay, and then say grant. So it will tell you whether you are able to give the access on this or not. So it says you must be granted use schema on its parent schema. So I have to first give the use schema on demo schema. Okay, if I just give access to table, they will not be able to access because I have to first give access to this, right? Because table is inside the schema. So you have to first grant use permission on the schema. So see here, when you come here, you say all account users, then use schema. Okay, demo schema, use schema, and then you can use any of these privileges, additional privileges. Either he can have create table, so he will be able to create table in this schema. Okay, create function, create volume, select, right? Everything on the objects within this schema. So once you give this schema, then you will go and give permissions to the objects within that schema, the tables. So all this you can also write as a SQL, or you can go to UI and give this schema permissions here.
So Arun, by default, it's always the Unity catalog, or do we need to do some settings?
No, right now default is Unity catalog enabled. Legacy is Hive Metastore. So there are many clients who already have workspaces with Hive Metastore, not Unity catalog enabled. So right now there are so many projects that are available in the market for migration from Hive Metastore to Unity catalog within the Databricks. Okay, so there's huge projects, there's a huge process that we build to execute those migration projects from Unity catalog to from Hive Metastore to Unity catalog. So that's one of the practice that we are building at Frisco Analytics, the UC migration projects. We are about to be certified with Databricks as a acknowledged partner for doing those migrations, that expertise. We have done the demos to Databricks team, provided all our capabilities, certifications, a technical demo we have given, how we will do the migration, how we are doing for partners, all the artifacts, the process flow, the migration guide, deck, everything. So we are about to be certified. Once we get that, Databricks will recommend us to the clients who wants to do migration from Hive Metastore to the Unity catalog. Because only if you have Unity catalog, you get a lot more features that are available.
So which version onwards it is available, Arun? I mean,
I'm exactly not sure which version, but yeah, we can check and get back to you. I'm not sure, basically. I will check that and let us know. I think with the Databricks Lakehouse, they started Unity Catalog. Maybe 2 years, 3 years ago, or almost, kind of. Okay. UC Workspace. See, this is the catalog. Now, in the catalog, you have to give use catalog first, then use schema, then select on all tables within the schema. So you can go to catalog, go to schema, and then go to objects. So you can create select object in all the schemas in this catalog. If you go at this level, create table at this level, or you can just give use catalog and use all schemas. And within the schema, you can go and give additional permissions at the table level. Okay. Now coming back here, this is what it is talking about the access control, giving permissions. So how do you manage row level security and column level masking? So row level security is like, you can create a function, okay, with name and parameters, just like any function, SQL, or in any programming language, you write create function. You just create that function and then return using that filter where you write where class. So create function, US filter, region string, return if is member admin true, region equal to US. Alter table sales, set row filter, US filter on region. So basically what they're doing is there's a table called sales. On that, you are setting a row filter at row level. Okay. On region. Okay. So this US filter, what is this? This is a function. So it will execute this function on each row of the table when you do a select. On which table? Sales table. This filter, and then you pass region, right? So whatever region you send, if the region is US, right, is member admin. So if you are, whoever is executing the query is admin, right? So they will get normally details, whatever you give. Otherwise, you get only the US region. Okay, at that, so you can do at that level. So if you see here, the same thing, you create a function, return expression, SSN mask, which means whenever you are asking data, it will not send you the SSN number. It should mask it with stars. Now, what it do is member admin. So if you are an admin group, you can still see the SSN. If you are not an admin, then you will see the stars. This is what it will return. Now, your masking and security is taken care of based on your permissions, access level. If you are admin, you are getting all data here. Otherwise, you are getting US. Here, if you are admin, you will get SSN as is. Otherwise, you will get stars in the place of SSN. And then you can add it to your table, whatever table it has. Set mask. Here, set row filter. So these are out of the box. Databricks gives you two important features for row level security and column masking. So again, you have to have the Unity catalog for this enabled. High leverage governance, Terraform. This is okay. Terraform is basically your infrastructure as a code where you can manage some of the infrastructure elements. So don't worry about this for now. Data sources and external locations. So think about it, just go through it. So when you have a user, you're requesting something. First, it will go hit the cluster, SQL warehouse. Then it will go check the access control. This user, what access does he have using the Unity catalog? And then it will write to audit log, whatever you are doing or activity. And then once you have access to manage tables, external tables or files. So based on your query, what you need, it will get and what you have access to. So if you have access to manage tables, you get this. And then you go to cloud storage or whatever storage where the data is stored, and then it will get the data. If it is external locations, it will go to external locations. So this is how you are, when you do a SQL or when you access something, what is happening? How are you getting back the data? Is through this. All of this happens. So basically, the lock here controls your access, your permissions through Unity Catalog before you go and hit all these objects and get the information or the data. Default access to storage by catalog or schema. So use manage data sources for data isolation or cost allocation. So basically what you're saying, you have Unity Catalog, Metastore you will have. Then you have multiple catalogs within the Metastore. Remember, we can say have multiple catalogs, and each catalog will have schema, and within the schema you will have objects, managed tables. So store at the catalog, store at the schema. Managed all these tables and data. File systems, how it accesses the read and write. So again, user, if he wants to do a write operation, access control, Unity Catalog. If it is read write, external location volume, you can go. If it is read only, select only, you can go to table and data directly to get. So read write, how it passes through the access control and Unity Catalog. I'll give you this. You can just go through, understand. You don't have to do this practically or answer everything, but you have to understand how it's happening in the concepts. Okay, so this is very interesting. This you should understand. And this is important because when you talk about your projects in the interviews, you should talk about this. So you have a Metastore, Unity Catalog. Then you see how you define your catalogs, development and staging. So you have a dev catalog, you have a staging catalog. So you have workspace, developer workspace, staging workspace, and you have groups, which are developers basically. So developers have access to which workspace? dev_ws. When they connect to this, they have access to dev and staging catalogs. So developers will ultimately have access to which catalogs?
Dev and
Dev
staging.
and staging.
Exactly, dev and staging. Can developers access prod?
No.
No, right? So developers can access dev workspace, staging workspace, which have dev and staging catalogs. Okay. But the staging workspace, testers, can testers access the development catalog?
Yes.
No.
No. Staging.
Development
Staging.
catalog is only given to dev workspace.
Staging. Yeah.
Staging workspace has only access to staging. See here, developers can access both dev and staging, but testers cannot access both. They can only access staging through staging workspace, dev. So if the testers want to go and access dev catalog, they should get access to dev workspace. Right?
Yes.
Okay. Now again, testers can have access to prod workspace here. See?
Yeah.
And prod catalog. But again, they may have a different group, different access to prod. They may have only the read-only access. We will define that. Analysts will also have the access to this. Then business user developers, a business unit. So you can have multiple catalogs, BU1 dev, BU1 staging, BU1 prod. Again, this is different business units. Okay. Let's say you have like multiple ancillary units. For example, you have pharmacy and optical, two different departments. So this can be pharmacy dev, pharmacy staging, pharmacy prod. Another can be optical staging, optical dev, optical prod kind of a thing that you can structure your catalogs. Again, so workspace can share the catalogs, right? Based on the access, which group has access to which catalogs through the workspaces. Okay, so BE users have access to BU prod workspace and BU1 prod only. They don't have access to anything else. So this is how the Unity Catalog governance model works, how the normally projects are structured. This is how exactly how the projects in the projects, how the access is structured with catalogs and workspaces and groups. Okay, so querying file-based data. I'll quickly run through this, not much too much into this. If you want to do a file-based access in the S3, how it goes, you send a query, one, it'll check namespace, metadata, and grants, Unity catalog here. What is your access? Do you have access or not? And then it writes to the audit log what you are doing. Then it will go and assume that role, IAM role, managed identity service account, what role you have to access this storage based on the user and Unity catalog that you have permissions. Then it return the list of paths data files. It will return all the path where the files are there with temporary tokens to the cluster. Then the cluster will use those temporary tokens and data files and go to the storage S3 or ADLS and give that token, hey, I have this permission, I have this role, and these are my tokens to access this. Then using that tokens, they'll get the data. It will return the data. So data is returned and sent to the user. Okay, so all of this happens when you access data from any of the file storage. Database, if it is, with Unity catalog within the database. So you go here, same namespace, Unity catalog, audit log, returns encrypted credential information to the cluster or warehouse. So it will give you the credentials to connect to that databases. And then you request ingest or data predicate push down by passing that credentials to the database. And then that metadata changes in the data are pushed to UC control plane. So if there is any metadata changed, it will get updated in the Unity catalog. Otherwise, it will return the data. Okay, so this is the process flow for database. So this is for the file and this is for the database. Volumes, as I said, you will have managed external. Let's see here. Yeah, see here. So within the schema, you have tables and you can also have volumes. So in the volumes, what you'll have files. You can store files here. See rows.csv, which you are actually accessing from any of these, notebooks or whatever. So of course you can have in DBFS also, or you can have your own volume created, which you can control the access to from you. So your local storage within your workspace, volumes. Okay. Volumes can be accessed, using DBFS again. So the location where you create, you can create within your volume or external volume also. So you can store unstructured data, images, audios, videos, PDF files, etc., which you use for ML, machine learning, all of this using the volumes in the Unity catalog. Automated lineage for all workloads, this we have seen. So it can build the automated lineage, auto capture, runtime data lineage, and Databricks cluster or SQL warehouse. So all this lineage is based on the tables that you refer and the SQLs that you run, and then the log that is written, audit log that it writes. You track the lineage down to the table and column level. Common permission model from Unity catalog. All the permissions again are from the Unity catalog. Lineage across tables, dashboards, workflows, notebooks, feature tables, and DLT. So you can get lineage from all of these, across all of these object types. How does it work? You have a ETL job, you have an ad hoc job, or you have a DLT. So if it is DLT, it will directly use the lineage service, table and column lineage. And then you can go and explore that lineage in UI, what you are showing within the Databricks as the pictorial or visualization of the lineage here, or you can use external catalogs to send that lineage to, and which can be used later. It can be exported via API. Again, ETL job or ad hoc job will go through the clusters, SQL warehouse, and then that cluster or warehouse we can use the lineage service from here. because DLT, it requests its own compute, right? So it doesn't go through this workflows cluster or warehouse, SQL warehouse. There's a built-in search and discovery. Again, so you look at nothing. It's just at the tables level. You can do. So you can go to tables here, quality, create a monitor. Okay, for data quality. There is an insights. So you can just do capture usage of this table, how it was used from notebooks or tables, dashboards, wherever from this was used. Lineage, so table name, how it is, used. So downstream, upstream, where it is used in each of these. So you get all of these lineage details that are built at the table level, what columns are used and all of that. History is not supported, okay, because this is a view. Compute not ready. Streaming table, permissions, history. So basically all of these, and then you can also go and define. See here, share via delta sharing. We'll come there. You can also add tags here. Yeah, this is what I was seeing. So you can add tags to the table, which will help later to understand what the table comments and tags, which will help in the AI where we are talking about, right? So if I say sales, it should know which tables have sales. So adding information as tags and comments will help the AI to understand which tables have that information, right? We have to give some kind of data for it to process and understand where the data is, right? So you have tables, UI to search. You can search for what are the tables, DB SQL and data science, machine learning, common permission load, apply semantic tags to data and search across tags. So once you have this, you can also search with tags, here. If you add, so you can search for tables, you can search with tags, then it will throw you all the tables which are having those tags, similar tags. Okay. It's just like online search only. If you search for one product with a tag, all products will have tags, right? Similar, all products will show up, which is having that tags. These are the discovery tags that I was talking about. So you go here, discovery tags, PI data, sensitive data. If you add, it'll help you when you're processing. It will tell you, so these tables have PI data. It should not be exposed, right? Or sensitive data. So all of that, you can have different permission levels set. Okay. Integration in UC allows you to search for objects by tag. That was what I was saying. So if you add tags, you can search by tags which objects, which tables have what kind of data. This is one last topic today before we wrap up, delta sharing. Okay. So as I was talking about, when you have, you want to send data to third party, share data. So normally, you export data into files and you send it, over the network to them. And then they receive the files and get the data. Instead of that, what you can do in Delta Lake is you have a delta sharing. You share the tables. When you share the table, they'll have delta sharing connectors. It will give you an URL, short-lived URL for this table, and that URL you can share with the user customer, and then they can use the URL to directly come and access those files. offer the data. So temporary direct access to files in the Delta format in the object store, whether it is ADLS or S3 or GCP, wherever the files are stored, they'll share the temporary URLs for those files with the tokens. And again, if you want to have a part of the data, it can share part of the files, not all the files, the cloud storage. So data provider, data consumer, there is an activation link. So once the time to live is gone, then he will lose the access to those URLs. So how does it happen? There is a Delta table, Delta sharing server, right? So recipient will request table. There is a short-lived URL that is given. You will have direct access to these files. So client authenticates to sharing server, requests a table, including filter. Server checks access permissions, generates and returns pre-signed short-lived URLs. Okay, so here is URL, go and take. Okay, and it is already signed, so you will have access when you access those URLs. Client uses URLs to directly read files from object storage here. So you don't have to generate files and ship it over network to them. Sharing happens on Delta part files, supporting full tables, partitions, Delta versions, etc. Client is system independent, just needs to be able to read Parquet files. It doesn't matter which system, what they are using, but since we are saying these are all Parquet files, they should just be able to read the Parquet files. In Databricks, sharing server and ACL checks are integrated with Unity Catalog. So this is in this sharing server, all the access permissions using the Unity Catalog, these are enabled, checked before giving those short-lived URLs to them. So this is called Delta sharing. Okay, so this is how it is done, sharing data with the third-party customers. Okay, so lot of reading, lot of knowledge, a lot of theory that we explored today, features. This is shared by Databricks itself. I will add this to our document, running document. You can go through these slides. Don't worry too much. You don't have to be expert. Nobody will ask you questions from this. It is only for your comfort, right? If you go through, understand these concepts, you will be more comfortable talking about. But again, don't throw all these terms because they might ask follow-up questions. Just tell them, I know, I have knowledge of these things. That's it. Don't say I have worked on Delta sharing. Okay. At least at this point of time, if you know, if you have knowledge and if you talk about it, I think that should be fine. Good enough. Okay. Any questions before we wrap up?
Harin, you told that there are a lot of projects are going migrating from my metadata to Unity Catalog. So are they using old version or new version? Because why they are moving from high metadata to Unity Catalog? And one other thing is, can we get any migration example? Can we do in the classroom or as a project, as an assignment?
Yeah, we can do. So it's not simple, but we can do. There is a okay. First question: why they are using, right? So as I said, Unity Catalog was introduced later, right? So all the customers which are using Databricks before Unity Catalog was introduced are getting default. So they already have everything on Hive Metastore within the Databricks. That's also a catalog, but it's just Hive Metastore catalog. Now Unity Catalog came in. So all new things are getting under Unity Catalog, but they still have that legacy Hive Metastore. So going forward, all their workspace, catalogs, objects, they want to move to Unity Catalog, right? So they want to integrate without going forward everything under Unity Catalog so that they can enable all the features of the Unity Catalog on all the existing ones tables, notebooks, DLT, jobs, whatever are there in the Hive Metastore, they can use with the Unity catalog once you migrate. Okay, so that is why they are migrating to Unity catalog, so that they can have all those features like serverless, for example, uniform, or any of these delta sharing. So all of these are by default enabled only for Unity catalog objects. So that is why everything they are moving on to Unity catalog within the Databricks. So can we do a lab? Yes. So you have to set up. So there is something called UCX, Unity Catalog X, which is given by Databricks. That's a GitHub project utility that you can download. You have to set up your environment to have Hive Metastore, one catalog with some objects, notebooks, and then you can run that kind of create one UC workspace, and then you follow through all of those steps to migrate. Do the assessment, figure out how many objects are there, create groups, migrate the users, groups, migrate tables, views, each object type you have to keep on. Yes, we can, you can set up and run a simple for a few objects. I will share that what Databricks is called. It's called if you just search, it's called UCX. You have that tool, migrate Hive Metastore to Unity catalog. Okay, so there are tutorial videos, and then there is this one. So there's a UCX, see here, migration tool that is given by Databricks. You can, so this is the UC migration flow that you do. So you run the assessment, and then you get your, you have to install UCX and then run that. You get assessment of what objects are there. And then there are different methods of doing Unity catalog upgrade, wizard, sync SQL command, and create tables and all of that. You can go through this, and then it's kind of a little advanced. I won't say not complex, but a little advanced to understand and go through this. But let me do one thing. So it'll give you, so this you can go, and UCX GitHub project is there. You can go and explore that, understand. So how to install UCX, how to do the assessment and all that. Install UCX and assessment workflow. So this is the GitHub projects. Run the job. Yeah, so when you run the job, you get something like this assessment. It will tell you how many databases are there in your Hive Metastore, how many tables are there, how many storage locations are there that you need to migrate to the Unity catalog from Hive Metastore. So it will give summary of all tables, upgrade what are tables, what is the type, is it a view, delta table, total grants, all lot of information will be there. 47 pages, kind of this. So yeah, I think we will stop here. Just hold on for a bit. And then we'll talk about, so you are good with what we have discussed, at least, right? Unity, what is Unity catalog, how data governance is done, how the data flow happens, what are the features, all of that.
Yes, sir.
Okay, awesome. Let me